In this video, we are going to be going through an example problem that involves two objects colliding at a certain position that we are going to try to calculate using our knowledge of position and velocity. So let's get into this question. Ball A is rolling to the right at a speed of 4 meters per second, whereas ball B, at a position 7 meters away from ball A, is rolling to the left with a speed of -6 times t meters per second. At what position will the two balls collide with one another? So here I drew out a little picture where we have ball A traveling to the right at 4 meters per second, and then ball B traveling to the left at -6t meters per second. And I also put at the bottom the distances, so we have 0 meters, and then we also have 7 meters. And then we have ball B traveling to the left at -6t meters per second, and that negative sign is to designate that our motion is in the left direction again. And we are trying to find where these objects collide. One approach that we're going to use to solve this question is the knowledge of when the objects collide, their time for their position is going to be the exact same. So what we are going to do is try to set the positions equal to each other and solve for time to get the position in the end. And we can see how far the object A is from its initial position to get the spots that they collide. So the first step that we want to do here is to recognize the relationship of the integral of velocity as a function of time is equal to the position. And we are going to use that relationship to get the position equations for A and B. So for A, we have the position for A as a function of time is equal to 4 times t plus our initial position for A. Same thing for B. We're going to take the integral of that velocity equation with respect to t, and we get -3t squared plus our initial position for B. Now our initial position for A we know is 0 meters, so that is 0, and our initial position for B is 7, so that is 7 down here. So we are left with our two equations of the position for A is equal to just 4t, and then the position for B as a function of time is equal to -3t squared plus 7. So now we can set these two different equations equal to each other because we know that they will be the same once they collide. So we can say 4t is equal to -3t squared plus 7. And now this is a basic quadratic, so let's go ahead and put everything onto one side. So we are left with 3t squared plus 4t minus 7 is equal to 0. Now this is a quadratic, so we can solve this in a couple different ways. We could use the quadratic formula. However, this one is actually going to be factorable, so we can go ahead and take 3t squared, and our two factors are going to add up to 4t, and their products are going to be -21. So we are left with positive 7t and -3t, so we have -3t plus 7t minus 7 is equal to 0. Our factors are going to be 3t times t minus 1, and then plus 7t minus 1. So our factors are going to be 3t plus 7 and t minus 1. Now in this case, we can immediately eliminate this factor because we know that time cannot be negative. So our time is t equals 1 second. So from this, we can actually plug this into the position equation for both of these. So we are left with the position at time 1 for object A is going to be 4 meters. And for B, it's going to be -3 times 1 squared plus 7. And that is also equal to 4. So we know that the position of both of these objects is going to be at 4 meters when they collide. So that is going to be our final answer of 4 meters. If it asks for how long it takes until they collide, it would obviously be 1 second, which saves us an additional step. But if it does not involve t, or if it involves an acceleration, you may just have to do an additional integration step in order to get your final answer. Make sure you like this video and subscribe to the channel if you don't want to miss out on any other helpful videos in the future. Thank you.